Yeah, hi and welcome everybody to our 2 days webinar about spiral wound technologies. My name is Matthias Mertens. I'm a civil engineer from Germany and CEO of United Engineering Team GmbH, a design and engineering company with one of its core businesses in the field of pipe rehabilitation. So in this first block of our seminar, we will have a detailed look on the different types of spiral wound lining technologies. In short, it's SWO, spiral wound lining. And we will start with an overview of renovation technologies according to the European standard 15885. So let's go ahead to the next slice. The EN 15885 is a European standard which describes actual renovation and also repair technologies. Yeah, its name is the classification and characteristics of techniques for renovation and repair of drains and sewers. And we will have a look at some of the renovation technologies at this moment. So here are some samples like the coating technologies with spray lining with cementitious or polymeric mortar. We have the mounting technologies such as pipe segment lining and the relining technologies such as lining with cured in place pipes, CIPP, or the lining with rigidly anchored plastic inner layer, RAPL. We'll get back to it later on. And also our spirally wound lining, the SWO. At this point, we should divide these technologies into manufactured on site and factory manufactured. So going to the next slice, and you see that some of these relining technologies are part at manufactured on site and some are part of factory manufactured technologies. So in particular, talking about spiral wound lining technologies, we have the RAPL, the lining with rigidly anchored plastic inner layer. It's more a manufactured on-site technology, and where you have the classic SWO lining, the classic spirally wound lining as a factory manufactured technology. The following graphic will explain a bit better the difference between these two groups of systems. So go ahead, I will make this a little bit bigger for you. So this graphic now shows the transition of quality affecting factors between the factory and the job site. So it means the more of the final product is produced in the factory, the more of the quality affecting factors are given there, like close fit lining, where the pipes are pre-manufactured in the factory. It's less quality affecting factors which are given on the job site. It's more or less given everything in the factory already. And on the other hand, the quality of the final product is more affected by the work performed on the job site, like with CIPP, the cured in place pipe lining, with its work steps like soaking the liner with resin, installing it by unfolding or pulling and curing the resin. And we do have our SWO, our spiral wound lining technologies, which are more or less in the left, so means more factory manufactured than on the job site. So the quality of the final product is more affected in the factory than on the job site. And we do have our RAPL, or rigidly anchored plastic inner layer technology, which is more right. It means we do have the same profile used for this technology than for the spiral wound lining. So it means the quality of the plastic profile is still given in the factory, but we do have some other materials like the cementitious mortar or concrete, which are then being mixed on the job site and cured on the job site, where we are with this technology more in the middle right of this graphic. In the next slides, we will go into more detail about the different technologies, but first of all, I like to show you the ISO 11296 Part 7. And this is an international standard which covers all the classic SWO technologies. Its name is Plastics Piping Systems for Renovation of Underground Non-Pressure Drainage and Sewerage Networks, Part 7, lining with spiral wound pipes. It is the part 7 of a series of standards for the renovation of underground non-pressure drainage and sewage networks, as mentioned. And as usual for this series, also the ISO 11296 Part 7 standard describes the properties of the materials in the M stage, means as manufactured, so before installation, when the materials come out of the factory and arrive to the job site. And it describes also the properties of the system in the I stage, so after installation, once the system is ready installed. It also describes the installation methods and how to reconnect, for example, to laterals and manholes, as well as the quality management and the documentation. The ISO 11296 Part 7 does only cover SWO technologies where the strength of the installed system comes from the plastic pipe only. So it means only from the plastic profile. And beside this, we do have another standard. It's the EN 16506. And this one covers, let's say, special spiral wound lining technologies, where the static load capacity is mainly given by the cementitious layer. So as mentioned, where we have cementitious mortar or concrete. And the name of this standard is Systems for Renovation of Drains and Sewers, lining with a rigidly anchored plastic inner layer. I mentioned this before, RAPL. And the standard is based somehow on the ISO 11296 Part 7. Like what I said, these parameters of the plastic profiles are linked to the ISO standard. And but the EN 16506 gives us more properties, more details about the cementitious backfilling, like the properties of the fresh mortar or concrete, of the hardened mortar and concrete, and also some special tests required for the RAPL system at the I stage, mentioned as installed. So, the new slice, classification of spiral wound lining systems, where I like to give you an overview about the different technologies covered, let's say, in these two standards we mentioned before. So on the one hand, make this one also a little bit bigger for you. So as you can see, I have divided the 4 types of spiral wound lining technologies into groups. It's A1, A2, B, and C. So the difference, or let's say the differences between these groups are mainly that we have with the group A1. There the winding machine is, let's say, installed in the starting manhole and stays there. So it means the winding of the liner is in front of the machine. So the liner runs through the pipe, and there we have a fixed diameter and therefore also an annulus gap between the liner and the hose pipe later on. And we have the technology A2, where the machine is also installed in the manhole and stays there. So the liner is also winded in front of the machine to the ending manhole with a fixed diameter first of all, and an expansion process later on. So it means at the end, when the system is installed, we have a so-called close fit lining. So the spiral wound liner is close fit to the hose pipe. Then we have the third one, it's the group B, where we have a self-running machine. So it means the winding machine is lowered down in the starting manhole and then runs through the line, through the rehabilitation line, and leaves the spiral wound liner behind. This one produces a close fit liner directly. So it means directly during the lining, the close fit liner will be formed, the close fit spiral wound liner. And last but not least, the group C. This one is also a self-running machine, so installed through the starting manhole and then leaves the liner behind with a defined annulus between the hose pipe and the liner, which will then be filled with the cementitious mortar or concrete as mentioned. And these 4 groups could be divided, as mentioned before, into the ISO 11296 Part 7. So it means A1, A2, and B are covered in this standard. And it is for circular shapes only, and also mentioned before, the static load capacity is only given by the spiral wound liner. And on the other side, we do have the EN 16506, the rigidly plastic inner layer where we can run through almost all shapes of hose pipes, and where we have the static load capacity given by the spiral wound liner, but mainly by the rigid annulus, which is filled with a cementitious mortar or concrete and some steel reinforcement in cases you need. But being said that for this technology, of course, this could only be installed at main entry pipes, so means 800 millimeters and above. So for a further explanation, we go to A1, and this is the technology as mentioned. The winding machine is fixed in the starting manhole, as you can see, and the annulus is later on filled with a filler with a grout. Yeah, and we do need a controlled water flow during the installation, but I will show you a little video in the next slides about this technology. So in this video you see the SPRPE technology, ICTIS UET technology being installed, and also some description for this.
The structurally lightweight liner serves diameters from 900 to 3000 millimeters or 36 to 120 inches and is suitable for gravity flow sanitary sewer and stormwater pipelines. The plastic profile that forms the liner is reinforced with steel that's completely encapsulated within the HDPE material. The steel reinforcement is selected to provide a liner with sufficient stiffness to meet the design requirements of the project. The SPRPE winding machine is positioned in the host pipe and winds the profile to form a new pipe with a fixed diameter. The profile is fed into the machine from a spool above ground. The winding machine joins the profile strips together and progressively forms a new pipe within the pipe. The diameter of the pipe is slightly smaller than the host pipe's diameter to allow it to fit through the existing pipeline. To overcome friction while winding, the sewer flow is controlled to float the liner and allow long rehabilitation sections. After winding, the ends of the liner are sealed and the transitions rendered. Lateral connections are opened and plugged. The annular space between the host pipe and the liner is filled with cementitious grout. The factory manufactured profile and mechanical installation process ensure a strong, high-quality liner.
So heading directly to the next group, A2, where the winding machine is also fixed in a starting manhole, but we will have the expansion process after the winding process. So also this video I like to show you is from ICTIS UET, showing the SPREX method.
Handling the smallest diameters in the SPR product range from 150 to 750 millimeters or 6 to 30 inches. SPREX has been used to rehabilitate over 1,600 kilometers or 1,000 miles of sewers and stormwater lines around the world. It has been proven capable of providing a structural liner for severely deteriorated pipelines and has been installed under difficult site conditions with minimal community disruption. Factory manufactured from pipe-grade PVC, SPREX has been used for trenchless pipe rehabilitation since 1990, improving flow conditions and extending conduit lifespans. After cleaning the host pipe and locating the lateral connection, SPREX can be installed. The SPREX winding machine is lowered to the base of the access chamber through a standard opening. The PVC profile is thread through into the machine from a spool above ground. As a first step, the SPREX profile is wound to a diameter smaller than the host pipe. The liner is held together at the smallest diameter by the secondary lock. Winding is stopped when the wound pipe reaches the next access chamber. The end of the SPREX liner is then torsionally restrained. Expansion of the liner commences by pulling the cutting wire, severing the secondary lock. As the wire is progressively removed, more profile is wound into the line. The lubricating sealant in the primary lock allows adjacent profile wraps to slide relative to each other. In response to the additional profile, the liner expands in diameter to fit tightly against the inside wall of the deteriorated pipe. The ends of the liner are sealed and the transitions rendered, after which the lateral connections are reinstated and sealed using appropriate methods. Once fully installed, SPR-EX is a close-fit solution with an intimate fit against the host pipe.
So we're heading directly to technology of the group B. So this one is, I show here, is the technology SPR-TF, also from ICTIS UET, quite new technology, where I only have a little animation, but there you will at least understand the winding process, this directly close-fit winding process. So as with the other technologies, the machine is lowered in the starting manhole as a self-running machine, and as you can see, the profile is directly wounded close fit to the hose pipe, so fed from the starting manhole to the machine. Some hydraulic hoses which are connected from the front of the machine. There you see the locking mechanism of this technology, where we have a mechanical sealing with some sealing bands, and the profile strips are locked with each other to form the spiral wound liner. And once you reach the end manhole, you just dismantle the machine, smoothen and reconnect the liner to the hose pipe, to the starting manholes, reconnect the laterals, and so on. This brings us to the technology of the group C, so the one which is covered in the EN 16506. And the technology shown here is the SPR-TM technology, also a ICTIS UET technology.
Designed for the rehabilitation of large diameter pipelines up to 5,000 millimeters or 196 inches. Circular, non-circular, and even custom shapes can be rehabilitated. The SPR technology can also be installed in vertical applications such as wet walls or access shafts. The SPR process is unique as it can provide a customized structural solution to aging sewer pipelines. It can be engineered to correct hydraulic anomalies as well as restore the slope of the original pipe. SPR was designed for installation in live flow conditions and can negotiate curves and bends. The environmentally friendly installation and application has proven its success in over 400 kilometers of rehabilitated pipes worldwide. After the host pipe is inspected and all incrustations and debris are removed, the SPR winding machine is lowered through the manhole and set up. The machine winds the PVC profile to the requested form and interlocks the PVC strips to a new watertight pipe. The interlocking edges of the profile create an impermeable mechanical lock. Optionally, a steel reinforcement can be used to withstand strong deformational forces. The bracing system is set up to provide structural support during the grouting process and positions the SPR profile in the host pipe according to engineering specifications. The ends of the liner are sealed and the transitions rendered. Lateral connections are opened and plugged. The annular space between the host pipe and the wound PVC is filled with a high-strength grout. After completion, the bracing system is dismantled, the lateral connections are sealed, and the rehabilitated pipe is ready for service.
And this brings us to a little comparison of SWO technologies. And first of all, I like to start with the technologies of the group A and B, so A1, A2, and B, which could be compared with the CIPP lining. So we have on the one hand the factory manufactured lining technology with the spiral wound lining, and on the other hand the on-site manufactured technology with the CIPP lining. We have different materials, of course. For the spiral wound lining we have we use PVCU or HDPE, so it means polyvinyl chloride or high density polyethylene, with or without annulus space, where only the filler is installed, so no static loads for the annulus, but only for the profile. And of course the access through standard manholes is possible, so it means 100% no dig technologies. And on the other hand, for the CIPP we use, as you know, synthetic fiber liner or glass fiber liner impregnated with different kinds of resins according to each technology. And typically for accessing the rehabilitation line, additional work is needed, like removing the cone of the manhole or even digging a pit to install the liner. And for the non-circular shapes, so it means for the spiral wound lining technologies of the group C, there we could compare to the GRP, the glass fiber reinforced pipes. So it means the short pipe lining. And we there have on the one hand the on-site manufactured technology, the SWO lining, and on the other hand the factory manufactured technology with the GRP. Both could cover all cross sections. With the spiral wound, we have the material PVC and the annulus space filled with the high performance mortar or concrete. And for the GRP, we have these glass fiber reinforced pipes with an annulus space as well, but there only a filler is used to prepare the load pass between hose pipe and GRP pipe. For the spiral wound, it is possible to access through standard manholes. So just open the manhole cover, bring everything in and install it. So it means there we have 100% no-dig technology as well. And for the GRP lining, of course, pits are needed. The bigger the pipe to rehab, the bigger the pit needs to be to lower down the pipe segments and to bring it in, to push it in. And one big benefit, of course, is for the spiral wound lining, the low transport and storage space compared to the GRP pipe lining, where we have like all these pipe segments need to be transported to the job site, need to be stored next to the job site. So it means there's a huge transport and storage space needed compared to the spiral wound lining of Group C. And the overpumping for the spiral wound lining, as we already saw in the little video, is nearly nothing. So in dry weather conditions, typically no overpumping is needed, or a reduced overpumping could be needed if we have a higher water level or a higher water flow speed. Yeah. Beside this, for the GRP installation, typically an overpumping is needed every time. So that's it for the first block. Yeah, and I like to make a little quiz with you. So it's a multiple choice test. Since this is a seminar, I like you to answer the questions given here. So the first one is, which standard covers SWO technologies with a rigid annulus, means static load bearing, also by the cementitious mortar or concrete? Is it ISO 11296 part 7 or EN 16506? Second question, are the SWO lining technologies manufactured on site or manufactured in the factory? Factory manufactured, manufactured on site, or some are factory, some on site manufactured? So I'm just kidding, I will give you the answers for sure. So the standard which covers the SWO technologies with the rigid annulus, where the static load is also beared by the cementitious mortar or concrete, is the European standard EN 16506. And as you remember, some of the SWO lining technologies are manufactured on site, some are manufactured in the factory. So that's it for the first block.